Okay. Now, you guys,
Take a whistle and blow it really loud.
please bell. Okay, I get your attention a different way. Do you know how many rats there are in New York City?
Yeah.
How many?
100,000. 100,000. Try 100 billion.
40 million. 40 million. And you know where the rats live? In the subway system. And the subways are all now flooded. So where are the rats? I did a workshop in Brooklyn, and I was coming back off the subways about 10 o'clock at night with my little chihuahuas. I'm walking back from the subway station to my hotel, and I see this is summer. There were a couple mice. Okay, mice. I was like, I don't like mice, but I was okay with that. But when I saw the rats, that's when I started running. And I supposedly chihuahuas will get rats, not mine. No, Mickey runs around all the time. They are really cute. I think chihuahuas should be fatter than what you see. They're much cuter fat. No, I introduced those dogs to the real chihuahuas in Central Park. I said, that's what you're supposed to look like. They didn't care. Oh, I couldn't even walk through the streets of New York with those puppies without people stopping me. I could hardly walk because they were so cute. They're in their little stroller. Okay. They love their stroller. All I have to do is get the stroller out, and they start jumping up and down. They think it's the best thing. Okay, we have to do implicit differentiation. Okay, Zach? You had time yesterday to be working on homework. You should have time today to work on homework, but I want to make sure you understand this. Okay, Michael? I think you can do this. It's not my question. I think the second time through, maybe you'll understand a little bit more. What do I mean by implicit? Now, if you have the new Inspire calculator, some, not all, implicitly defined functions you can graph on the Inspire calculator. I could look at that today if you want me to. For instance, if I have x squared plus y squared is equal to 9, we know what that graph is. It's a circle, but it's not a function. So you can't put it on your graphing calculator unless you solve for y. Okay? Pay attention, please. Okay, Alex? You can solve for y. In fact, if you do y, it's equal to plus or minus the square root of 9 minus x squared. We'll do one of those. In fact, this one probably. That's the top half, and then the negative is the bottom half. This is explicitly solved for y. You guys do it all the time. You will explicitly ask somebody to do something. Okay, Zach? I'd like Zach to pay attention. That's explicit. There's implied. It's implicit when I maybe just look at him and I don't say anything. We do implications all the time. And you'll say, well, why didn't you understand what I wanted you to do? I implied that you're supposed to do this. That's what would get you in trouble, the implied ideas. Well, in math, I don't mind the implicit ones because I'm not going to solve for y explicitly. I'm just going to leave it like that and take the derivative. And that's why it's so important to know what we mean when we take a derivative. So solve for y in terms of x explicitly, implicit, the sum of the terms in both x and y, not solve for y explicitly. So not y equals, okay? And a lot of times, it's easier to do it implicitly than explicitly. Well, now in the Inspire calculator, I can actually type that in, and it will graph me the circle. So it's not a function. They fixed it so it could do that, which was kind of cool. So there's my x squared plus y squared equals 9. It's the equation of a circle. Is it implicitly defined or explicitly? It's implicit. So if we explicitly solve for y, I gave you the answer, but let's do that. Y squared is equal to 9 minus x squared. And how do you get rid of square roots? Well, I square root both sides. Be careful with this. It isn't plus or minus. Because if I take the square root of 9 on my calculator, I don't get plus or minus. I get 3. I don't get negative 3. So when I do this, y, the absolute value of y, not y, is equal to the square root of 9 minus x squared. And obviously there are math teachers that don't realize it's not plus or minus. Where do I get the plus or minus? When I solve for y, remember? I want to put numbers in there that make the equation true. Well, the absolute value of y is what is equal to 9 minus x squared? Well, that one. or this one, the minus sign, 9 minus x, the square root of 9 minus x squared. Okay, one's the top half, one's the bottom half of the circle, because you can't graph the whole circle because it's not a function. And to take the derivative of that is not fun. Well, it's not that bad. I would do this. Now, in AB calculus, they don't want to label the derivative. And I think you guys realize you have to label everything. You can't just write the derivative down and not tell me it's the derivative, because I don't know. Remember, I'm an AP reader, and if you don't tell me what something is, I'm not allowed to assume, even though it might even look like I know what you're thinking. They will not let me do that. So if I want the derivative of this, I'm going to have to write y prime equals. Well, how do we find the derivative? Chain rule. So it's 1/2. Lori, what's next? To the what? Negative 1/2. And then I still have to chain it. Times what? Negative 2x. I don't know about you, but I think that's pretty ugly. Well, I'm going to clean it up, make it look nicer. What happens to the 1/2 and the 2? They're going to cancel. So y prime is going to equal negative x. Then when I take this negative 1/2 exponent, puts it in the denominator, makes it a square root. Now, I did that really fast. Are you okay with that? And that's the derivative of 1/2 of the circle. The other one is going to be the negative of that. Well, what if we do this implicitly? Said it wrong. What if I take x squared plus y squared and I don't solve for y?
You do the dy dx. Oh,
The operator is not dy dx.
no, but then
Okay? I don't want to see that now because we're calc 2. It's d dx.
I don't want to see you.
And then the classic mistake is the derivative of 9. What is that? And that's 0. But and it gets you in trouble when you make it 9. Okay. Now, what I'm asking you to do here is find out how x squared changes if I change x. What's the derivative of x squared with respect to x? 2x. Now, the derivative of y squared, but with respect to x, is not as simple. First, I have to have the derivative of y squared with respect to y. When I say it's 2y, that's with respect to y, not with respect to x. Times, then I chain it, times the derivative of the inside function. Yeah, but I got to make sure you get this. And that's equal to 0. So when you say that this is 2y, that is the derivative of y squared with y. What's the derivative of z squared? Because what's the derivative of y squared? Remember, y is some function of x. I can rewrite it that way, and it'll become clearer to you. I'm not done. And then you have to chain it times the derivative of the inside function. The outside function was the squaring. So if I change x, y changes. If I change y squared changes. And if y squared changes, y to the 4th changes if I have a whole bunch of stuff there. So it's dy dx. Some of you, and you get away with it, it works for you, you memorize. But I have to have a dy dx there, or else I'm in trouble. Yeah. And you can solve for dy dx. So 2y dy dx is equal to minus 2x, right? And so dy dx is equal to minus 2x over 2y. And what happens to the 2's? Sorry, I was going to do that too fast. So dy dx is equal to minus x over y.
Our college test is graded as retarded as AP test.
What does that mean?
I guess like
Usually, if you get 50% right in a calculus class, you're going to get an A.
You should give Graham the SBR.
no, I mean like you know how they're super like nitty gritty, so they're gonna grade like that in college.
No, it's worse than that in college. If you don't have the right answer, Eric, if you don't have the right answer in college, it'll take a problem like this and make it a 25-point problem. How they get 25 points, I never could figure out, but anyway, they do. And if you don't get the right answer, you get 0 out of 25. It depends on the professor. It just depends on the professor. I had to go to bat a couple times for the kids. I said, that's not fair. Okay. Okay, you guys? Shh. What is y? We know what y is. We solve for y right here. It's the square root of 9 minus x squared. So if I substitute it in here, dy dx if I want to. Now I'm going to make some other things here. Is that the same as I got over here? Yes. And I'm sorry, my board is. Okay, Ori? Oops. Now, what do you think? Which was easier? In terms of the calculus, this is easier. And do you remember that we, later on in the year, chapter 7, and we did it last year, we were given equations that involved derivatives and whose solutions were functions. Do you remember what those were called? Differential equations. We're just doing the derivative. Where do differential equations come from, John? They come from implicitly differentiating a function. Yeah. I want you to see those connections. You can, because you've had the whole course. Now you can stand back and look at it. Second year of calculus, when I taught it, I couldn't walk in and teach it. Not the second time. Not even the third or fourth time. I had to prepare my lessons, figure out exactly what I was going to teach. Well, now I've been doing 21 years. I better be able to do this with my eyes closed. So you guys have only seen this once. You imagine yourself now in Algebra 2. You should be getting more depth. I don't know if you do, but you should be getting more depth. So now I want you to get a deeper understanding of the calculus. That's why I give you the hard problems, not the easy ones. I know you know the easy ones. Okay? Well, that's all you have to do. If we don't, and now we are not going to solve for y and put it in there because half the time you can't. So let's do another problem, like that one. Can I solve this for y? Now your font is better than this. I don't like this font. Can't. It's not even possible. Now, can I put that on my graphing calculator? I don't think that's one of my options. It's limited, but I can put some on there. If you have Mathematica, you can graph this on Mathematica, but that costs money. It's a computer program that will let you do all this stuff. And I don't have it, so that's why it is, because it costs money. Not like Mathematica. That's like 500 bucks. Now, I think when you go to the university, you will be using Mathematica. They'll have it in their labs, or they'll have maybe MATLAB or something, but it's probably Mathematica. Another place to look at stuff like this is Wolfram Alpha. And Wolfram Alpha is now starting to charge. You can, yeah, they only let you do 3 questions in a day, and then after that you have to upgrade. So I don't blame them. Why should they give away all this stuff for free? Okay. Okay, you guys ready to take this derivative? Grant, you haven't taken any derivatives. Let's take this derivative. So what's the operator? It's like doing a plus sign or squaring, square rooting. D dx.
More like we have a 3-day weekend this week.
Yes, it's very nice, isn't it? Okay. Zach, do you know how to do this? Now, it's with okay, Eric? Okay. What's the derivative? Grant, write it down. Alex, do the problem. What's the answer? What's this? No, I want this part because not everybody's there. Okay. Guys, then don't talk. If you're not interested, that's fine. That's your problem. But what's the derivative of the sine of y? Because I got to make sure kids get this. Cosine of y. Now, that's the derivative of the sine function. It's how the sine function changes if I change the inside function. Okay. Is that making sense? Because it didn't last year to you, for the most part. For a number of you, it probably did. But for the bulk of the kids, no. They could kind of memorize their way through it. Okay, and then you now have to see, well, if I change x, how does y change? So you multiply by the derivative of y with respect to x. Why do I know this? My daughter taught at Colorado, University of Colorado, Boulder, and she said the kids could never get the implicit differentiation. And I said, well, that's because they don't know what a derivative means. How does something change if something else changes? Okay, what rule do I have to use for this one? Product rule. So it's x times the derivative of y with respect to x. We call it dy dx. That's just a shortcut name. What is it again? Plus y times the derivative, and I write it out, of x. I mean, initially I do, with respect to x. What is that? It's 1. It's asking for the slope of y equals x. You could think mathematically that dx's cancel. Which isn't quite right. They want you to know it's not quite right, but it works. So this is 1. And then I'm hoping they ask me to find the slope at a point, because I don't really want to solve for dy dx, but we will. So it's 3x squared plus cosine of y. I'm just going to clean it up, because I can't work with it like that, equals. Now, Mrs. Hersman makes it y prime. Personally, you can do that. It's fine. I lose the primes along the way, because it's easy to lose. So I like to keep dy dx plus y. And to solve for dy dx, and this really helps you understand what it means to solve, I want dy dx all by itself. So I've got to get the dy dx terms, those separated by the plus signs, on the same side. Now I'm going to do a little bit of blackboard magic. I'm going to leave the cosine of y, dy dx, whoops, forgot that, times dy dx on the left side. And I'm going to take this x dy dx and put it on from the right, and put it to the left. So it's going to become what? Minus. Now, I hope, because you guys are really good in math, you should be able to do that quickly. If not, show the steps. Okay, and then I don't want that 3x squared over there on the left side. Subtract that, so it's going to be, this y is still here already, minus 3x squared. Now, what do we do? I'm factoring that out. That is why when you say 3x plus 5x is 8x, right now I'm not teaching that. I said, okay, you have 3x's and you have 5x's, so you have 8x's. But that's because I can factor out an x, and I know how to do 3 plus 5. That's the reason why it's 8, though. It's not because you're adding 3x's and 5x's, really. It's because you factor that out. Because what if I have 3x plus yx? I could factor out an x, and I'm left with 3 plus y if I wanted to solve for x, for instance. I'm just making these up. Okay, Grant. So what we're going to do is factor this out, right? So dy dx times what, Grant? I'm going to factor it out. I colored it. Use color if you need. Cosine y minus x equals y minus 3x squared, and now we need to solve for dy dx. Bring what to the other side?
Like, you know how you subtracted
I did.
x dy dx and put it on the left side?
Yeah?
I subtracted cosine y.
Oh, it won't matter. You'll have a negative side.
Well, yeah, I have.
Well, let's finish this and let's see. Hang on. Well, we're going to check it. Now, you guys are to the point where you should be able to check these now. You should be, not as good algebraically as I am. I've been doing this for 40-some years. Or longer. I don't know. I always have to think about that. But, in first-year algebra, no, I don't expect them to check it. But what if we multiply by -1 over -1? I know if it's right. So it's 3x squared minus y. And then this would be x minus the cosine of y. So both have to change, both numerator and denominator. Did you get it right? They're both right. Because what's -1 divided by -1? 1. Listen. I want you to get deeper into the mathematics. Sect. Pardon? Over 2.
What you saying, Holmes?
I have 1, 2, 3, 4 terms. Yeah, but you got to do the derivative of the side. Now, one thing that I do to remember, okay, guys, guys, is if I don't have a dy dx here, then how can I solve for dy dx? Okay, so it's just a little trick. Now, if they ask for the slope of the tangent line, I will not solve first. I will put in the x and y values right there. So it's easier. Okay. In fact, asked you to do that. Find the derivative of y with respect to x for each of the above examples, which we did. And now, I don't know why that's on there twice, now that I think about it. Now, write the equation of the tangent line at 0, 0. I'm going to copy my derivative. I'm going to try. That's this little guy. Can I do this? I would do it in this step. Okay. What's the equation of the tangent line? If you guys know any 8B students, please help them because they're having a hard time with it. How do you write the equation of any line? It's y minus y1. And honestly, I don't even have any idea what that looks like. But if you have Mathematica, you can look and see what it looks like. It's m x minus x1. Okay, Eric, how do I do this? Okay, do I know the x and y coordinate? Yeah. It's 0, 0, right? That's 0, and that's 0. So all I have to do now is find the slope, which is dy dx. So I know that, and so I'm going to put in my 0, 0. So I'm going to have 3 times 0 squared plus the cosine of 0 times the slope. How about if I just call it m? Equals x, which is 0, times m plus 0. See why I want to do it now? Remember, x and y are both 0. Want me to call them dy dx's? I will. I just called it m because it was easier. So that's 0 plus, what's the cosine of 0? Do I need to review that? 1. Good job. Equals what? 0. So what's the slope equal to? 0. Not much of an equation of a tangent line here, is it? So this is 0. So it's y minus 0 equals 0 times x minus 0. So y is equal to what? 0.
Wait.
I found the slope. I put my values in here rather than solving for dy dx first. It's easier. Okay. Pardon? Well, I've got a couple more examples here. Oh, I didn't take this page out. It is out of yours. We're not doing orthogonal curves. Does anybody know what orthogonal means? Means perpendicular. So the curves are perpendicular to each other. So if you had a curve like this and a curve like this, where the tangent lines is, they would be perpendicular, which they're obviously not there. But so they're not orthogonal curves. But we're not going to do that. It's beyond what we need to know in this course, and we have a lot we need to review and to do. Okay, let's introduce the trig functions, our favorites. I don't know what the derivative of inverse sine is. Can you solve that equation for x? Might as well just get started on this because we have a lot to talk about tomorrow. Yes, you can. X equals, well, let's prove it. X is equal to the sine of y. Because if you forget, you need to know this, but if you forget, we can do it implicitly. Okay? And now we're going to find the derivative with respect to what? X. There's going to be the little trick here, and then I'll have you do the tangent. And these are the two you need to know. You have to memorize these. Okay, what's the derivative of the left side? 1 equals the cosine of y. Remember, the derivative of the cofunctions are all negative. Times dy dx. So what's dy dx? That's the time sign. Doesn't look like it. Now, this is not an okay answer. That is not an okay answer. We need x's in there because we want to find the derivative of the inverse sine. I don't want any y's in there. Remember, y equals inverse sine of x. Okay, let's just draw the picture. Now, there are these identities you can memorize, but I don't want to do that. So this means the sine of my y angle is x over 1. So here's y. Okay, you ready? Matt? The sine of y is x over 1. Grant, how do I get this other side? No, Pythagorean theorem. 1 squared minus x squared. It's just Pythagorean theorem. Okay. Now I need to go up here and find the cosine of y. What's the cosine of y? Is the adjacent over the hypotenuse. So it's the square root of 1 minus x squared. Because, you guys, that is what a trig, inverse trig function is. This is an angle. And it means the sine of what angle is x? That's good. Those are good questions, though. And when I see inverse trig, I should be seeing angles. So the depth right here, this is 1 over the square root of 1 minus x squared. Now, the derivative with respect to x of inverse cosine is the same thing, except it has a negative in it. So there's more than one answer if you had to integrate that with a negative sign. That's okay. So do you guys want to try tangent, or do you want me just to give it to you? You guys should do it. This is what you should get. Now, what's the derivative of tangent? Secant squared. So do you want to try it yourself, or want me to do it? Now, these are the two you memorize. You don't have to know secant or cosecant or cotangent. Well, let's do this. I don't want you to memorize it. I want you to understand it. Y equals inverse tangent of x. So what does that mean? This means that the tangent of my angle is equal to x, right? What does that mean in my picture? Corey, what does that mean in the picture? When you are given an inverse trig, you're given an angle. Okay, Ori. So my angle is y. If the tangent's x over 1, then this is x. This side is what? 1. And how do I find that side? It's not that bad. There you go. Okay, now we have to take the derivative. What's the derivative of this? Some people told me. Okay, Eric, what's the derivative of tangent of y?
Secant squared.
Of y times what? dy dx equals?
Why does this class always feel like different?
1. Okay. dy dx, there's a couple ways to do it. Is 1 over secant squared of y, Ori. What's another way to write that? What's 1 over the secant? Cosine. That's the cosine squared of y. What's the cosine of y from over here? The cosine of y is 1 over the square root of 1 plus x squared. So, what's cosine squared? It's that fraction squared. Ask me. These guys up front are kind of noisy. Cosine, you can do it either way. I can either work with the secant or I can work with the cosine. Abby. What? Because my triangle was different, because I have the tangent of y is equal to x. It's a different angle now. Okay? And that ends up being 1 over 1 plus x squared. So you're going to have a bunch of these with the chain rule. I gave you that orange sheet. What is, I'm kind of introducing tomorrow's, what is the derivative of inverse sine of f of x? Yes. What's that one? It's 1 over the square root of 1 minus f of x squared. And I'll hit on this again tomorrow, times the derivative of the inside function. Okay, so we'll do that again tomorrow. Are there questions on anything out of sections 3.1 and 3.2? Corey, where's your book?
My book? I don't have one.
Why don't you have one?
I had pneumonia for like a week.
Well, you need a book. How are you doing this? Online?
How was I doing what?
Doing your math. No, that's not good enough.